Okay, section 1. Section 1's hard because there's limits on everything. And for those of you who've taken calculus before, you're sitting here going, I know an easier way to do this. Don't you? So others of you are like, I don't know what she's talking about. That means you haven't had calculus before, which is fine. But those of you who've had a little bit of calculus before, this is the section you were hoping I was going to do in 2.1. Now, that said, you're going to have a limit problem on your test, and you'll have one on a quiz. So you definitely need to practice. You need to be able to do the limit definition of derivative. All right? So what we did in 2.1 is the basis for what creates what happens in 2.2. Everybody likes the shortcuts, right? But you have to recognize that somebody did the long cuts. My kids call them long cuts when we do a shortcut that's not, right? Long cuts. A lot of times before they realized, hey, there's a shortcut. I could do this easier in a different way. So 2.2 is you stepping on the shoulders of somebody who did a lot of work before you. That's what it really is. Okay? That said, it is going to make your life a whole lot easier. So the first thing I'm going to do is to let you write down some simple derivative rules. So that's what section 2.2 is basic or simple derivative rules. All right, so the first one is the constant rule. The constant rule says that if you take a function a function who has a constant value, f of x equals c, its derivative is 0. And just like that, you have the answer no limits showing up. Okay? The second one is the power rule. I'm pretty sure the power rule is the only thing my husband remembers from taking calculus in high school and in college. He took calculus in college. He remembers the power rule of all things. I don't know why that's the one that sticks out, but it does. The power rule says that if you have a function x to the n, and n can be anything, whole number, fraction, decimal, positive, negative, it doesn't matter. N can be anything. Its derivative is nx to the n minus 1. So it looks like that the exponent becomes the coefficient, and then the exponent decreases by 1. No matter what the exponent was to start with, positive, negative, fraction, decimal, whole number, integer, anything, all good to go, decreased by 1. The constant multiplier rule says that if you have a constant c multiplied by a function, you just drag it along for the ride and you multiply it by whatever you would have gotten without it there. So you take the derivative and then you just multiply it by whatever's next to it. The sum and difference rules, again, are exactly like you would hope. If you have two pieces added or subtracted together, you just work with them each individually and then you add or subtract from there. So I take the derivative of the first piece, and I take the derivative of the second piece, and then I put whatever sign was between them again. And then your book puts the simple derivatives for just sine and cosine also in this section. The derivative of sine is cosine. And the derivative of cosine is negative sine. And we're literally going to do the two first examples because they're that fast, and then we'll stop for today, okay? Okay, you ready? Still got a couple people writing. Let me slow down just a touch. Okay. X to the 7th. It's a power, right? So I do the notation y prime. Okay, whatever it is on the left-hand side, it just gets a prime stuck on it. What will x to the 7th become? 7x to the 6th. And we all said hallelujah, right? I don't know about you, but I don't want to do a limit definition with a power 7. That sounds awful. The next one has two rules at play. Okay, so there's a notation f prime of t. The first rule at play is there's a pi at the beginning, and pi is just a number. Y'all know that. Feels a little funny to think about it that way sometimes, but it's just a number. So I really have this constant multiplier rule. That c in the front, this is the pi in the front, it's just going to come along for the ride. So there's just a pi. And then I have the cosine rule. And what's the derivative of cosine? Negative sine. Now, this looks funky to leave it written this way, so we will rewrite it so that I have the negative in front of the pi. But other than that, that's all the simplification there is to do. Sound good? All right, we'll pick up with some more simple derivative rules on Thursday.